Hello and welcome to my video on music and sound effects for Nintendo DS. So in this video I will show you the sound manager code that I use in all of my DS games, and I will also explain using 256 color sprites as well. It may seem a bit odd that I've lumped the sprites in with this video. This is the scrolling game. It will be the demo being sort of remade using Mario here, and these other sprites will be our sort of enemy sprites. So first off, I'll get through the sound stuff first, and then once I've gone through the all of the sound details, I will then at the end of the video go through all of the usage of 256 color sprites. The reason why I didn't pack in the 256 color sprites into their own video was that they're pretty much the same as the 16 color sprites. There's only like a small change, but the small change can catch you out. And as I found out when mixing them together, which you can do, 16 and 256 color sprites, can be a bit of a pain doing that. I hadn't previously give it any thought to doing that, but the bullet sprites are being reused from the 16 color sprites demo, and as a result I thought to just chuck in the 16 color sprites and the 256 color sprites together, but that caused a bit of an issue, so I'll talk about that here as well. So first off, let's go through the audio capabilities of the DS. So it's got 16 sound channels, which is a good number. I'll talk more about what this kind of means as I go through some of the tools, but basically each sound channel, you could think of it as being able to play one like wave file. So that's 16 potential different layers of sound there. So those are hardware channels, which means there is like a dedicated area to sort of handle that one sound channel without them all being sort of mixed together in a sort of like bucket area of memory. So the various formats it can play, so we can have 16 PCM8, that's basically 8-bit pulse code modulation files, so wave files basically. That's how I would sort of like think of them. So it can handle 8-bit and 16-bit, and then this here is a kind of like compressed audio format, and it's like a variable format apparently. It's PCM again, but it's like a compressed version. Or you can have the some of the, or 6 of the channels can be used to act like the Game Boy Advanced or the Game Boy PSG chip. So if you want to use that functionality, then you would have to sacrifice some of the sound channels for that. I'm not going to be going through any of that, as all of the stuff I'll be using will be purely using either wave files or tracker files. If you visit the website here, the Problem Caput site here, there's a bit about the sound on the DS, and I'm sure you'll be able to get all of the details for using it to simulate the Game Boy Advance or the Game Boy's chip if you go through there. So there's also 2 sound capture units, which I won't be going through at all either. I've not used these, so I can't give you any info on that. I'm not really interested in recording sounds from the DS, but I've included it here as this is some of the capabilities that it has. The sound library I'll be using will be the Maxmod library, so the link to it is maxmod.org, which gives you a fuller breakdown than what I will be going through here. So each of the 16 channels, they occupy 16 bytes in the input-output region of the DS, as it says there. So as I was saying, yeah, according to GBA Tech, the DS has 16 hardware sound channels. You can play sound samples, or basically, as I said, simulate the programmable sound chips of the Game Boy Advance or the Game Boy. Thankfully, we won't have to code bits and bytes and words here, as the sound library that Maxmod gives us kind of allows us to sort of abstract away sound, so we can concentrate on using it in a nicer way. And my sound manager code will also assist with that as well. As I was saying, the sound manager code, which I'll present in a bit, is literally like a kind of if we were programming in C++ or any other object-oriented language, it would be I would consider it a class, which I just drop in all of my sort of projects, coding on the DS. Similar sort of functionality as well on the Game Boy Advance. So the tools we'll need to work with sound are Audacity, which is this program here, and Schism Tracker. Obviously, if you are familiar with any other trackers which export to the .it, .mod or .xm file format, then you are welcome to use those. I'll briefly step into Audacity and Schism Tracker to show you some things with it which are useful. So in Audacity, you can basically take any sort of WAV file or any other sort of audio file. Really, it supports various formats, and then you might want to rip part of a song possibly, or someone speaking in a song, or some other audio. You can do that with Audacity. You can take like a song and you can literally cut a part out of the song and then edit that and then change the format of it. One of the key things with us working with a DS is changing the format of sound, because the main media type on the DS that takes up the maximum amount of memory is sound. Sound eats memory like there is no tomorrow, basically. And unless you are streaming on the go from like an SD card or something like that, then we are limited to about 2.3 megs in total, is the sort of size that I've found in the projects I've made. So most of the time that means you'll be having to sort of come to compromises with sound. So I'll get into these here. So I'll jump to the websites from now so you can see what they look like. So thankfully these tools are open source and are cross-platform. So as you can see, we've got a Linux build here, Mac OS, and various versions of Windows there. So that's Schism Tracker there, give you an overview. And then our next tool is Audacity. So as you see here, we have an app image for Linux, universal binary for Mac, and we have our 32 and 64-bit Windows versions here. And then another site I would recommend coming to, as it has lots of mod files ready for us to use in our own projects. So unless you are a musician, then you might want to come here and try and find some template music, if you like, until you sort of get to grips with creating your own. So what I would recommend is go into show filters. As I said, the maximum amount of channels that the DS has is 16. So I would say 16 in there. And then format here. The formats it supports is .it, .xm or mod. For this example, we'll just go with IT. And then we'll put in a name, just say Mario, because that's bound to have something. And then here we go, here there's some things here. So some stuff to be aware of is the file size. I mean, look at that, that's massive. But you can get these files and then edit them down. So for example, some of the music I created in my Ring Dash games for the Super Nintendo and the no, pretty much, yeah, Super Nintendo really. Some of these files were not friendly to the Super Nintendo, so I had to go in there, open up the files themselves, and all I was really interested in is the music, pretty much, not the sounds, not the sound effects. So these mod files, what they consist of is they have like a few sound effects, and those sound effects are pretty much mapped to you can think of like sheet music, like the notes that you need to play, the duration of each notes, all that sort of stuff, which is why usually the mod files are a lot smaller than standard music files. Obviously this one is very large, so we'll go back and have a look at one of the others in a minute. This one's a bit better, it's only 45k. If we have a quick listen to that. Okay, so that sounds pretty good, so we'll download that. Right, let's find a place to put all of this. So I will bung this in here. So I've downloaded that now. I already have example music for us. So now what we'll do is I will open up Schism Tracker, and then I'll show you some bits and pieces with that. So I will navigate to where that is. So one thing to note about Schism Tracker is it's like an old school tracker. Most of the way that you manipulate things in here are all via keys. So F1 brings up the all of the details with keys. So you pretty much, to work with most things in here, it's keyboard and mouse. Predominantly keyboard though. So this just tells you some of the key bits and pieces here to change the various screens, as there are different types. So F1 is for help, and then escape takes you back to wherever there. F2 brings you to the what these are basically look at a list of sound that will be played on one of the many channels. So this is a note, this is an octave, and this is the sound sample associated, or rather the instrument associated with it. So if you press F3, what we have here is we have a list of sound effects or wave files which are associated with the music in general. So there's a number of different ones in here. So you can, if you notice here where it says play, all of the green ones, these, there are physical waveforms in there. You can see this alter in here. And then these are the various details of these sound effects. So if you hover over the play part here and you start typing keys on your keyboard, then what will happen while your mouse is hovering over here is this sound effect will be mapped to the frequency of the note. So the way that what this actually does is it kind of creates like a, so if I press F2, F2 takes you back here. So you've got, these are called pattern tables. So each of the notes here you can think of these as like potentially being like a virtual instrument. If I press F11, what this is showing here is this is like a list of all of the pattern tables which make up that song. So as you can see, there are 15 pattern tables, or rather there are 15 entries in here. But as you can see, there are only actually 9 pattern tables. So you basically plug in like a pattern table into like a play order here. As you can see, it goes 1 0 2 3 4 2 3 4 5 6 7 8. So you kind of like loops on parts of itself. So this also helps you to keep the size of the music down as well, where you've got like areas of a song which play over and over again. And then you can sort of change panning here as well. Not all of these things will be supported on the DS. So what I would recommend, if you press F10, no, sorry, not F10, it's F9, F12. Right, so when you create music, you generally want this to be on instruments. And then I would normally go with mono because obviously that's going to take less memory, but it probably doesn't really matter too much. And then stick with linear here. So these are kind of like, this is like kind of like some additional sort of format here. I can't sort of tell you all the details with using this tool, as I am not an expert. So when you go to the download page, there is like an instruction manual. You might also want to look at the Game Boy Advance and the SNES music video as well, as there will be parts in there which cover this tool, which I might not cover here, as I'm not totally sure what I covered in the other ones. I don't sort of keep like a huge sort of script and everything of what I've kind of said before. So how you sort of create your music is you start plugging stuff into these channels here, and then to play back what you've put in, you press F5. F8 stops it. So F5 gives you that view there. F2 takes you back there. If you press F6, I think F6 just plays the current pattern table you're working on. So you'll see here, this is a pattern 1 here. And then pressing the plus and minus buttons on the numpad if you've got like a full-size keyboard, will cycle through the various pattern tables. See a number changing here? If you don't have that, then you'll have to physically change this number here. So you would hold down, if you hover your mouse above this, hold the left mouse button down, and then you can move whilst holding that down, scroll that around. That applies for most of these things here as well. So you see there's a number of different instruments there. You can select different instruments. So to get these notes to kind of play, in fact what we'll do is we'll go to a, in fact I'll tell you another thing as well. So these you'll see here it's got rows, so you decide how large one pattern table will be. So one thing to note as well is these will all be different sound effects here. So you've got the note there, the octave, the sound effect, and then what you can also have here is the volume. That's what this is kind of doing here. It's changing the sort of volume. So some sounds will kind of continually sort of play into each other. There are various bits and pieces you can sort of add to sort of change that. So in F3 here, you could have some of these things, these wave files changed here. So what you can also do as well is you can save these out. If you press F1, then this will give you some of the shortcut keys here. So you can see here we can save a sample in an exported format if we press Alt and T. So if you press Escape again and press Alt and T on there, you'll see we've got a name here. Unfortunately, you'll see that it didn't actually give me an option of where it's saved at, so now I need to try and find where it's actually dumped that. I suspect it's in here. Most of the time it dumps everything into the home folder or the home directory here, which on Windows is equivalent to kind of C drive, I guess. Or it used to be. I have no idea where it's put that. Damn, it doesn't matter anyway. What I'll do is I'll quickly show you an example of something being edited in I must have closed another folder. Where is it? Nope, here it is. I'll show you a sound effect here. So these are some sound effects, and I'll show you one being edited in Audacity. So this is our sound effect here, and then if you do this, it'll play it. So this is 11 Hertz at the moment, this sample here. So one of the key things you might want to do, by the way, this is fine for the DS, but for example, say it wasn't, then you might want to change the frequency of that sound effect. So to do that, you would go and click Resample. We'll upscale this to 22 Hertz. And then when you click OK, you'll see that the wave has increased here. That means we've put more detail into it. One thing to also make sure you do as well is to change the project Hertz to match what you've just set there. Otherwise, when you export it, it will not pick up the correct rate or frequency. So now what we've done there is because we've changed this here, we might want to amplify it slightly. So Control and A to select everything there, and then we'll amplify that. And then what you can do is you can change the speed or the pitch of that sound effect so that it might not be recognizable as the original. So it's currently recognized that this is kind of at G5, which is octave 5. And then what we're doing here is we are upscaling it to E6. So if you preview that, yeah. Okay, let's not do that. Let's go down an octave. You get the idea. And then all you would do is you would export that then as a WAV file. Pick somewhere where you would want to save this. So in this case, this is automatically found the sounds demo folder, which I was working on before, with the various sound samples in there already. I'm not going to save it, but so you could start off using 16-bit PCM, which obviously gives you more details. But then you, if you're running out of memory, then unsigned 8-bit PCM is an option as well. Sometimes that still sounds fine. And some of these are in various formats, either 16 or 8. Those are the only ones I would take from there. And that's how you would sort of export there. I can't really give you too much details on Audacity here. I'll kind of just use it for basic sort of editing. If you had a song, what you could do is you could highlight parts of it by dragging with the left mouse button there, and then you could use the cut there. That's cut that new part out. If you click new now and then paste that in, and if you hold down Control and zoom in, that's what we've pasted in. There's not enough of it to play there. This is literally like, this is not even a one, it's like 0.5 of a second there, so you're not really going to hear anything. But just that's an example of you can sort of clip bits and pieces out of songs or any other sort of speaking or recording you might want, and then you could export that, play with the bass, treble. There's some distortion in there as well, and there's a reverb which causes like a kind of echo effect. So all of that is very useful for sound effects. So if we go back to here, you could then create those sound effects. One of those could be part of a note, and then you could load them in, and it would be like a WAV file like this. And then you can change how this sound actually plays here. So to demo this, you use the so Z to M is like the bottom octave. So it's defaulting to octave 4 there. And then press in the various. So notice there they've put like a loop. What that means is the song is the sample plays once and then it gets trapped continually playing that loop. And these numbers here dictate that. So you can change the loop setting here. So we've turned that off. this is what the default was on here. So these numbers here, you can change these. As you can see there, the loop begin part is where this loop would start, and that's where the loop would end. F8 will stop the sound from playing. As it's on loop, when you press a key to play it, it will continually play all the time. Some of these sounds, what happens with loads of the mod files is when you sort of get them, you find that they're packed full of loads of sounds which the composer put in there but never actually used. I had this issue with some of the songs I was sort of editing and restructuring, where it wouldn't play on the Super Nintendo because there was so many samples actually in there which weren't even used, and then some of the samples were not even playable on the Super Nintendo because the sound chip couldn't read the sort of the ranges which it was using. But the key things to take away from here is the actual notes themselves. So you could record, make a note of these, and then literally re-input them into your own tracker program with your own instruments. So if we put another one in here, all you need to do is you're pressing a key on the keyboard. So you notice it's picked up. So what you can do as well is if you click on these other channels, you'll turn them off. So only the active channel you're mucking around with will actually do stuff. So pressing F7 will start playing from where you left off, or rather where your cursor is currently. So I'll leave this here. It was a quick sort of go over of Schism Tracker there. Might be some more info from the SNES and the Game Boy Advance. So now what I want to jump into is the actual code. So that's the file that we've taken there. So what I'll do is I'll show you how we would actually how we would even include that. So this is our project here. When you're working with sound files, you need to alter your make file slightly, and you'll also need a folder called audio. So I would recommend when you sort of having any projects which have sound in is just to copy this make file here, or even just use this project as like a blueprint for your own and just delete what you don't need. And then in the audio folder here, you'll see I have some music and some sound effects here. So this is the song which I got off of Mod Archive for playing in here. This one plays fine. But for this example here, we'll paste this other one in, and this will be our second song. So what we'll need to do is have our audio folder open here, because we will need to include the name of this into our project. So I will open this up in Code Blocks now. In fact, what I'll do first is I'll actually show you the project so you can actually see what we're looking at here. don't know if you can sort of hear that playing, but there's like I think it's a MIDI file I found ages ago of like Summer of '69 or something, which worked. It's got no singing, so it's kind of open source to some degree. So if I press start here, this is literally a rehash of the 16-bit Sprites demo, except we're using 256 colour sprites now, except for the bullet of our player, which is either Sonic there or Mario there on our converted Motorbug. And then if you press start, as you can see, the music and the sound effects. Let's close that. I'll let you play around with that. So the music and the sound effects make a big difference to a game. It kind of brings it alive more, I would say. Like, so the all of that sort of code with the main sort of game was covered in the 16 color sprites one. So I'm not going to dive too much into that. All I'm going to cover first off in this first part here is the sound manager. So as I said, we are using the MaxMod sound library, which is included with DevKit Pro, and then using this header here, which is types or structures, if you like, which are linked to the MaxMod library. And then what I tend to do here is create an enumeration of all the sound effect files. So if I minimize some of the things on view here, and then come back here, organize these by types here. So you see we've got a number of different wave files here. So all of these have been edited and formats changed to kind of restrict the amount of memory that they use, purely so that it all works fine with the DS. Notice if you use wave files for music, which I have here, they take up a huge chunk. So use them sparingly, as I've done here. There's the main sort of music is the title. This was stripped back as well. I cut a load of it out just to create like a small sort of loop. And then we've got a game over sound file from Sonic as well. There's two different level clear sound effects. Wubba lubba dub dub. That's one, and good job. That's the other. So to include these, what you need to do is you have these in your sounds folder first off, or sorry, audio folder, and you need to make sure that in your make file, I'm using the text editor to quickly show you, you make sure that you have the audio folder piped into this sort of like build target here. And then in the flags here, there's also this one here, I believe it is. This is the MaxMod 9 library. And then you would also have bits in here for building the sound bank binary. So the sound bank bin or binary, and some of these other lines in here. Where are we? This bit here. So what this will do is it will go through the audio file here, your audio folder, and then it will build binary banks for the DS automatically for us, and then it will create in the build folder. There will be, where is it? It will create a soundbank.h file and a soundbank_bin.h. And then if you open these up with a text editor, this tells you how much memory they take up in the soundbank.bin. But the this one here is the important one, the soundbank.h, as this tells you what names it's given to all of the sound files which you will need to map everything against. To be able to work with them, you need to know the IDs. So these are basically a load of defines that MaxMod's created. So to be able to work with them, you need to know the name given. For example, the in our sound effects array here, this dynamic array here, this is of type sound effect, which is a MaxMod structure, and this structure here expects an ID for the sound effect, the speed at which it will be played at, and then a pointer for something else which we will be passing null to, and then we have like the volume, default volume setting, and the panning. I've described what these things are in the source folder here if you'd look at. So you see all of these names here, they are all included in here and need to be laid out like this. So in your own songs, and in your own projects, just make sure that you put all of these things in here. So the catch with it all is that these names will not actually appear in this folder, or this file will not exist until you actually build it for the first time. Hence, we don't have the other IT file. So to get that one, we will need to build this. So now that that's built it there, close that, and then we need to reopen that file. Where are we? In build, and then come back to that there. There we go. So that's the other one there we've just included. So we'll now need to add that name to our list of IT files here. So you notice that these are different types here. So the music files, basically all of these, they all have like an ID reference to them. So what I do here is these are basically lists of the one is a list of the sound effects and the other is a list of our mod files, which in our case we're using it.it files here. And then to access them in a nice easy fashion here, I'll create like a blank enumeration. So we have one where I tag everything as eSong to designate it as being a mod file music, and then everything else I just tag ESFX. So what you need to do is make sure that these numbers here match the order you put the sound effects in here, so that you can then just say. So what I try and do is I try and have these function names and everything as as basic like as possible. If you've ever coded in BASIC from the sort of like 80s or 90s, you'll see probably more so 90s going forward, like Visual Basic, for example. You'll see that most of the function names are kind of easy to sort of see what's actually going on. To me, these languages, obviously this is in C, but languages aren't important. It's what they do that counts. So I kind of want everything to be as simple as possible because the game is the overall creation. The language here is just a means to represent the game, really. So try and keep things as clear and as simple as possible, which all of these sort of things are. Another thing to note here as well is this sound effects speed fall is actually this. So you see what's actually happening here is like at 1.0 is obviously normal speed, and then you can increase or decrease the speed here, but this is, you could include the different speeds when you define the sound effects. You can alter the speeds later on, I believe. One thing I would encourage you to do, which is what I've had to do as well, is to look in the actual header files for this. So there's a lot of info in here which can prove useful when working with MaxMod 9. There's more stuff you could do with the sound effects and music than I've done here. These are just kind of like a basic thing here. So some of these numbers here, these are just numbers which MaxMod expects to be present for changing the volume. So I've just enumerated as much as I can here. The functions are fairly straightforward. At the start of the program, you'll need to call sound init, and then what this will do here is this passes our sound bank to MaxMod. It then selects like a playback mode. We're using mode C. It says in the docs it's extended mode, so I'm not sure if that means it will allow more than 16 channels by mixing some of them. And then we first off go through, because we've used our enumerations here, we can use the numbers generated by the last entries in our enumerations as being the sort of like index, how many there are. So to load a mod file, you need load, and then the type it expects in there is a short. So all we're passing in is these IDs here, and then the load effect, it expects an sound effect type, but it expects the ID. So if you look at this data type here, then it tells you all here what's actually going on. So the zeros we're passing in here is like a no pointer to the sound effect handle. We don't need that. As you can see, these are byte values here at the end, so a number between 0 and 255. So panning of 0, I think, is the left, fully to the left speaker, and 255 is fully to the right. So 128 is halfway between them. And then you'll see the volumes set to 255 for each of these. So this here is a very simple setup. You literally just drop everything in that you need. And then there's not a lot really to discuss here, really. music wise, I usually play things on a loop, but if you have a look through here, you've got loop or play once. Most of the time with music I usually want it to loop, but obviously you can add more functionality as you wish here. Maybe you could just add an extra parameter there and play music to set whether you want a song to loop or not, you know. And then we've got sound pause, sound resume. These are just for music, not sound effects. The effect files work slightly differently. If you hover over them, you'll see what is expected from the functions. Most of these things here you can get from the sound effect type. So most of this is straightforward here. To change the volume here, we're literally just converting these numbers into this word type, and then that sets the module volume there. As you see, all of these commands are fairly straightforward. So that's pretty much that really. Not going to make any changes in there. In fact, I do need to make a change actually. Need to demonstrate to you that the and then what we will do to illustrate that, or rather show that off, let's go to the title stream code. So what was happening in here before is when this was initializing, we are playing the sound effect title. I'll now comment that out. And then we'll play that one instead. Build that. So just remember at the start here that you will need to, where are we? You need to initialize the sound manager to be able to use anything. As some of the initialization code, I think, hooks in some interrupt code. And then once you've done that, you're good to play whatever. So now let's have a look at what we've as you can hear, that's totally changed now. I will now change that back. So playing sound effects and whatever is as easy as that basically. The hard part is basically editing your sound samples and finding music which is right for whatever project you want. So that's it for the sound part, and now I will talk about the 256 colour sprites. Right, so one of the things that occurs with 256 colour sprites is so they take up twice the amount of memory as a 16 colour tile. So what that means is if you're using them on their own, as in you're just having a whole project of 256 colour tiles, then that's fine. Just make sure that you keep track of the tile IDs in memory where the sort of graphics tiles are. So as this little diagram illustrates here, the DS only sees tiles in 16 colour format. What that means is it only sees tiles as being 32 bytes in size, so its tile IDs are separated by 32 bytes. So when you want to use a 64 byte tile, you have to make sure that they are aligned to the right sort of ID. So what this is showing here is this line here is showing that 6 tiles in memory, and then this area here is showing the tiles we want to use, the memory footprint they take up. So as you can see here, one 256 colour tile at the very start would use up these 2 tiles in the DS's memory. So when we wanted to use our second 256 colour tile, it's not actually going to be here. It's not going to be, the ID to use it won't be 1, it will actually be 2. And then if you wanted to add in a 16 colour tile for ID 4 here, you'll see that it fits in fine. But then to add in our third 256 colour tile, we then need to make sure it comes after the fourth one there. One thing I'm not sure about either, which I haven't actually tested, and thinking about it here, I don't know whether if we put our 256 colour to an odd number, whether that will glitch out the graphics or not. I haven't tested that. Before this project here, I hadn't even bothered to mix 16 colour and 256 colour sprite tiles, as I didn't really see a point in doing so. But for this demo here, I thought, okay, let's do that, and then that created a whole load of headaches, which I hadn't thought about before, which are all due to the tile arrangements and having to align them. So another thing to bear in mind when you are working with 256 colour tiles is you will need a palette plan. Ideally, in a massive game, obviously you're not going to maybe have that whole 256 colours static all the time. So there might be like a colour range which you'll want to swap out. It's also hard to have like a proper graphics package these days that actually allows you to work properly with large sort of colour palettes, and also to save them into the correct sort of format as well. So for example, you can disregard these. I got over enthusiastic about the project at the start, and then quickly realised it would turn into something else. So instead, what I did was I restructured to limit the amount of different sized characters I was working with. So our players have up to 27 colours. So what you want to do when you sort of build these is come up with a colour plan. So our players started at colour 0, and they ended up using 27 colours. Our enemies, what I'll do is I'll bring up the graphics so you can see who I'm referring to and what I'm referring to here. So another thing here as well is these tiles are actually they're actually really large as well, which is another thing I wanted to sort of show. Obviously, the maximum size sprite you can have is 64 by 64 in size, which is what I've done here. As you can see, the motorbug ship that our player's on is moved all the way to the right, and our player is just plopped right on top of him like. So here they kind of all use the same sort of colours, which is fine, but there's 27 different colours here, and I only knew that there was 27 colours when I used the graphics converter program, which if you've followed the videos up to now, you'll be aware of. So to create 256 colour sprites, all you would do is select 256 colour tiles there, make sure that you put in the sizes of them, so 64 by 64 for our player ones here. And then this box is important when working with 256 colour sprites, as this is the start colour that the sprite data will be mapped to. Like I said, by keeping track of the start colour and the total colours, you then know that, for example, we know here that the bad sheep characters start at colour 27 and they have 34 colours in total. So that colour range between 27 and what we got there, and 61, if we swap, we can swap those colours out if we're not using the sheep, or those colours could be used for other enemies on a different level or anything else, but we then know where those colours are. Now the bullets, they are 16 colour, so it's not too much of an issue with these, because we literally you just have to then decide which area of the 256 colours are going to be used for only 16 colour sprites. So you could half the palettes. So you could have, say, like 0 to 128 was for 256 colour sprites, and then maybe the other half is split into palettes. So palette 8 to 15, and then that just makes things nice to work with then. So for our players here, if I come to pictures again, so we've got our players, drag and drop over. It's because it's there's no palette in here. So as I've not defined the palette, we need to make sure we select, get the image from palette mode, which is that one there, and then drag and drop it again. There we go, and then that tells you how many colours it's found. So then we know when we export this that the next character should start at 27. So if I open up the different sheep, you'll recognise these from the bitmap demos. Slightly altered, a little different colours there for making it more interesting. So with these, one thing we want to do is we don't want to include this background colour here. We want to remove this, and also these are 32 by 32 pixels in size. And also note that there's 12 of them as well. So to sort them out, we do 32, 32, and then we start that at 27. We leave that to strip the palette colours from the image, but what we also want to do is we don't want to include the first colour as the background colour. So what we're saying is this first colour here, which is the background colour, we don't want it, so don't include it. So then what it will do is it will replace in the output the background color here with the color index 0, which is what we want. What we'll do now is we'll drag this one across. It's found 34 colors, so make a note of that. As I did here, 34 colors. But I think it's actually, I think that color it's told us it's actually 33. And the reason is it takes into account the background color, which obviously we've told it to disregard. And then once you save that, so I'll just record over the previous one. So what was it? Space sheep. There we go. We'll replace that. There you go. It's found 12 tiles. The reason why you keep note of all these different things is because there could be some issues or errors or something, and it helps you sort of track them. So now if we look in here, I'll also explain this as well. Yeah, so you see here it's dropped one of the colors, so it is actually 33. And then the tile data is arranged into 8x8 tiles, 8x8 pixel tiles. So each of these 1 bytes represents one color. This is the palette colors associated, starting at 27, and these are those colors here. So you would just copy and paste all of this into the project. And that's how you would work with different sprite assets in 256 color mode. Now if we come back to here, so let's see what I've changed in the Sprite Manager stuff. Everything's pretty much the same in here, except for I've added is the Sprite 256 color. And now what we need to have is we need a function to set our tile data. As I said before, one 256 color tile now takes up 2 16 color tile spaces in VRAM, but of course the DS only ever sees 16 color tiles in its memory footprint, so you need to sort of multiply the start ID by 2 to get to the real place where it's going to be. And obviously the tile count now obviously takes up the tiles in 256 color tiles, not 16 color tiles, so it actually takes up twice the amount. But to keep things nice and simple, the functions are pretty much just the same, except we changed the sort of pass in parameters and the names slightly. Obviously we don't need to worry about a palette ID now in 256 color tile mode. And behind the scenes I've kind of kept all of the other functions exactly the same, which most of the time they are, as the DS will handle everything else for us really, as long as we tell the DS that that tile is a 256 color tile. So I changed the bank we're using for the sprite, but there's no real reason to do that. It turns out that the 1024 256 color tiles only takes up 64k anyway, so there was probably no need to switch that one. But I'll leave that anyway, as I don't want to tinker with anything that might break the project at this point in time. So the only thing I'm going to go through with this is the passing the 256 color tile data to the DS. So it's pretty much exactly the same as the 16 color one here. I decided it was best to keep the tile IDs to the 16 color tile placements in memory, as it gets very tedious. If you're not using any 16 color tiles though, what you can do is you can just work with offsets of 32 bytes from the very beginning, or rather words, because the sprite graphics handle that's provided for us actually maps the region of memory which is in unsigned 16s or unsigned words into a format that allows us to treat that area of memory like an array. So this is actually in unsigned shorts U16s. So the actual size of this is actually double. But to work with 256 color sprites, we obviously have to convert our tiles to bytes. And then when we copy these into memory, we need to remember that we are copying 64 bytes per tile. Hopefully that's not too confusing via there. So the only thing we need to change really. So some of the stuff I've had to handle automatically here. So we can change frames as easily as we could in the 16 color sprite demo. So if you've not seen that one, I would recommend seeing that one just so you understand what I'm talking about here. The frame tile count needs to be times by 2 to allow us to change the frames in memory. That and our color mode is obviously OBJ color 256 now, not OBJ color 16, as per the where are we, the new in the new 16 color sprite. You'll see that the color mode is OBJ 16, and we need to assign the palette to the OAM object structure. We don't need to do anything to the palette in 256 color mode because obviously we're using them all. You just need to make sure that the color mode is 256 there. So that's pretty much the only change I wanted to sort of talk about. Obviously some of the code for the bad manager has changed slightly. By all means have a look at that. I think this video's gone on for long enough now. So hopefully this will be useful to you. I wanted to kind of pack the 256 color sprites in here as I want to end the 2D section of my videos, and next time I'll be delving into the realms of 3D graphics creation. So I didn't want to include any sprite stuff in there, as that's kind of, that would be counterintuitive to 3D. So have a look through and have a play around with this, and good luck with your projects, and I'll catch you in the next video. Any questions, I might be able to sort you out with answers when it comes to sound. Right, yeah, any questions, drop them below and I'll get back to you and answer them if I can. Right, catch you next time.